lighter than aluminum, stronger than steel, and the future of engineering. But how is carbon fiber actually made? The journey begins far beneath the ocean, where crude oil is extracted from deep underground, forming the foundation of one of the world's most advanced materials. Before reaching land, crude oil is carefully purified offshore, preparing it for the refining process that will create the building blocks of carbon fiber. Thousands of meters below the ocean, advanced engineering safely brings crude oil to the surface. Across hundreds of kilometers travels to a refinery, where it will be transformed into the essential chemicals behind. Inside the refinery, heat separates crude oil into valuable products. One of them, naphtha, will become the foundation of carbon fiber manufacturing. Refined into pure naphtha, this vital petrochemical feedstock begins its transformation into acronyl, the key ingredient behind every carbon fiber. Inside these giant reactors, advanced chemistry transforms petrochemical feedstocks into acrotyrol, the essential building block of modern carbon fiber. Millions of molecules bond together to create polyacrylonitrile, or PAN, the remarkable polymer that forms the backbone of every carbon fiber. After careful mixing, filtration, and purification, the PAN solution is prepared for the most delicate step, forming thousands of continuous microscopic fibers. Thousands of microscopic filaments emerge from precision spinnerets, transforming liquid polymer into the first continuous fibers of future carbon fiber. After careful washing removes every trace of solvent, the purified PAN fibers are prepared for the next critical step, precision stretching.
Precision stretching aligns millions of polymer chains. This gives each delicate PAN fiber the strength and uniformity needed for its transformation into carbon fiber.
After careful drying removes every remaining trace of moisture, the PAN fibers are finally ready for the critical heat treatment that begins their transformation into carbon fiber. Inside the oxidation furnace, heat and oxygen permanently stabilize each fiber, preparing it for the extreme temperatures that create true carbon fiber. With stabilization complete, the fibers are ready for their greatest transformation, entering oxygen-free furnaces where only pure carbon will remain. Inside an oxygen-free furnace, extreme heat removes every non-carbon atom, revealing the ultralight, incredibly strong material known as carbon fiber. At nearly 1800 degrees, the fibers become almost pure carbon, gaining the remarkable strength and durability that define this extraordinary material. At temperatures approaching 3000 degrees, carbon atoms align into perfect crystal structures, unlocking the extraordinary strength that makes carbon fiber exceptional. Electrochemical treatment creates billions of microscopic bonding sites, allowing carbon fibers to permanently unite with advanced composite resins. A microscopic protective coating shields every filament, ensuring the carbon fibers remain strong, flexible, and ready for the world. Every filament is wound with microscopic precision. These are aerospace-grade fiber spools. Every spool undergoes rigorous aerospace-grade testing, ensuring each carbon fiber meets the extraordinary standards required for the world's most advanced engineering. Thousands of carbon filaments are aligned with microscopic precision, preparing them for the weaving process that transforms loose fibers into advanced composite fabric. Thousands of carbon filaments are woven into a flawless fabric, creating the lightweight, ultra-strong material used in aircraft, race cars, and spacecraft. Artificial intelligence examines every millimeter of carbon fiber fabric, ensuring only flawless material moves forward into the world's most demanding applications. Laser-guided alignment systems continuously correct the fabric's position, ensuring every millimeter remains perfectly straight for the next stage of production. Computer-controlled tension keeps every carbon filament perfectly aligned, preserving the flawless weave required for aerospace-grade composite materials. Layer by layer, hundreds of meters of carbon fiber fabric are wound into a flawless master roll, preserving perfect alignment for every future composite application. Advanced AI inspection verifies every layer of the master roll, ensuring flawless carbon fiber fabric before it moves to the next stage. Stored under tightly controlled conditions, every master roll is preserved in perfect condition before continuing its journey toward advanced composite manufacturing. Once selected for production, the master roll is retrieved automatically and delivered with pinpoint precision to the cutting department, ready for its next transformation. Before cutting begins, the fabric is carefully flattened and stabilized, ensuring every carbon filament remains perfectly aligned for aerospace-grade precision. Every carbon fiber kit receives a permanent digital identity, ensuring complete traceability before the material enters Prepreg manufacturing. Before it can bond with carbon fiber, the epoxy resin is blended under strict aerospace controls to achieve exceptional strength. Removing every microscopic air bubble creates a flawless epoxy resin, ensuring maximum strength and defect-free performance in every carbon fiber composite. The epoxy resin is cast into an ultra-thin, perfectly uniform film, creating the foundation for the next step in aerospace prepreg manufacturing. Carefully controlled cooling stabilizes the resin film, preparing it for the precise lamination process that transforms carbon fiber into advanced prepreg. With perfect alignment achieved, the carbon fiber fabric meets the resin film, setting the stage for one of the most critical steps in prepreg manufacturing. Heat and pressure bring resin and carbon fiber together, creating the first stage of prepreg, where every filament begins its transformation into an advanced composite material. Precision calibration ensures every sheet of prepreg meets exact aerospace specifications, with perfectly balanced resin content and uniform thickness throughout. Every carbon filament is completely saturated with aerospace-grade epoxy, creating a perfectly balanced prepreg ready for the most demanding engineering applications. Controlled cooling stabilizes the resin without curing it, leaving the prepreg perfectly flexible and ready for protection, storage, and future composite molding. Protective release films preserve the prepreg's delicate resin surface, keeping every sheet clean, stable, and ready for advanced composite manufacturing. Hundreds of meters of finished prepreg are wound into precision master rolls, preserving every layer until the material is ready to become a high-performance composite. Stored at sub-zero temperatures, the prepreg remains perfectly preserved. This locks its performance in place until composite manufacturing begins. Before shaping begins, the prepreg is carefully conditioned to the perfect processing temperature. This ensures flawless handling without triggering the curing process. Every prepreg ply is cut with microscopic precision, creating the exact shapes that will soon become some of the world's strongest and lightest engineering structures. One precise layer at a time. Robotic systems build a composite structure whose strength comes from the exact orientation of every carbon fiber. By stacking carbon fibers in multiple directions, engineers create a composite structure capable of withstanding enormous forces while remaining incredibly lightweight. A lightweight honeycomb core dramatically increases stiffness, allowing massive aerospace structures to remain incredibly strong without adding unnecessary weight. The final carbon fiber layers seal the lightweight core, transforming individual materials into a single aerospace-grade composite structure ready for curing. Before curing begins, every layer is sealed inside an airtight vacuum bag. This ensures perfect pressure distribution, flawless composite quality during the autoclave process. A perfect vacuum removes every trace of trapped air, ensuring the composite is fully compacted before entering the autoclave for its final transformation. After passing every inspection, the composite enters the giant autoclave, where heat and pressure will permanently transform it into an aerospace-grade structure. Inside the autoclave, intense heat and pressure permanently cure the resin. This transforms flexible prepreg into an incredibly strong aerospace-grade carbon fiber composite. After hours of precisely controlled curing and cooling, the carbon fiber composite emerges permanently hardened, ready to be released from its mold. After curing, the finished carbon fiber component is carefully released from its precision mold, revealing an aerospace-grade structure engineered to microscopic perfection. Diamond cutting tools machine the cured composite to microscopic tolerances, creating the precise dimensions required for aerospace assembly. Millions of laser measurements verify every curve and dimension, ensuring the finished carbon fiber component matches its digital design with microscopic accuracy.
Without making a single cut, advanced ultrasonic and CT scanners inspect every hidden layer, ensuring the carbon fiber structure is completely free of internal defects.
The final protective coating preserves the carbon fiber's strength and appearance, preparing the finished component for decades of service in the world's most demanding environments. From microscopic carbon filaments to a flight-ready aerospace component, this is how advanced carbon fiber transforms the future of engineering. From raw polymer to aerospace perfection. This is the journey of carbon fiber. See you inside the next factory.